Hello everyone, my name is Ken Chen. I'm from the University of Minnesota. Today, I'm very happy to have the opportunity to share my research with you. I will talk about the cosmic dawn, physics of the first luminous objects in the universe. First of all, you can see my pictures. Now, I'm sitting at my office at the physics building of the campus. Before I start my presentation, I would like to thank to my outstanding mentors, including my advisor, Professor Alexander Hager, Professor Tom Jones, Professor Stan Worsley, and Professor Walker Brown. Without their support, I cannot carry out my research. So when you walk into a dark room, you just simply turn on the switch, and the room will be light up. But how do we light up the universe? It needs stars. But when the universe was born, there were no stars or galaxies. So my research is trying to understanding the formation of these first stars and galaxies. So my approach is using the numerical simulation. So I'm writing the numerical code, including the relevant physics of the early universe, and run the simulation at some of the biggest supercomputers in the world, including Franklin and Harvard at the Lawrence Berkeley Lab, Itasca at the Minnesota Supercomputing Center, the Jaguar at the Oak Ridge National Lab. So here I'm showing a simulation about the formation of the structure of the universe. Those dark points represent the cold dark matter particles. So later they evolve into highly clustered structures. Inside the dense clump or halos, the star will form. And what the physics behind the formation of these stars is following. After about 400 million years, when the universe was born, the dark matter collapsed into halos, and the halo provide a potential well, allow the gas to flow in, and form stars. When the star forms, the star will emit the radiation and change the property of the surrounding gas. Eventually, many of these stars die as a supernova and eject a lot of material and energy into its surrounding as well. After another 100 million years, those material and structure will collapse fall into a more large-scale structure. Inside that more large-scale structure or halos, we can form many more stars, so-called the first galaxy. But this still model haven't been verified yet. So my research is trying to understanding about this process. So first of my project is trying to understanding the evolution of the first stars, especially when they die as a so-called supernova. Another key point is how the feedbacks from the first stars impact the formation of the first galaxies. So here I will show a movie about the formation of first ever stars and his radiation feedback to its surrounding, and the supernova explosion, and how the supernova eject material to enrich and change the property of surrounding gas. In the case of this star form into a binary instead of single star, then there will be a possibility for X-ray emission. So it's a 4-in-1 movie. goal of my research is try to provide the predictions of the observational signatures of the first stars, supernova, and galaxies, and they will probably be observed by the future telescope, especially the James Webb Space Telescope (JWST), which is the successor of Hubble Space Telescope. Many thanks for your attention. My research has been kindly supported by many funding agencies.